Okay, this is going to be part 5 of the video series on trigonometric integrals that use sine and cosine. And in the part 4 video, we did a couple of example problems that use sine and cosine to even powers, but in that video, they were all to the sine squared. So now what we're going to do is take a look at a problem that involves sine to the 4th power. So let's see what the problem looks like. Okay, so what you've got is this, the integral of sine to the 4th of 2x. Now the problem we run across immediately is that you don't have a formula for sine to the 4th, but you do have a formula for sine squared, so let's go back and look at our identities. So using the half angle identities, the sine squared is equal to this. So the trick on this problem is to change that sine to the 4th into 2 sine squareds. So what we'll do, the initial step will be to go ahead and split this up into the following. We'll make it be the integral and change the sine to the 4th into the sine squared of 2x, and again times the sine squared of 2x. So both those together are equal to the sine to the 4th, but the reason you did this is that you have a formula for both these two right here. So let's take a look just to remind you of what that formula is. The half angle formula for the sine squared, it's 1/2 of 1 minus the cosine of 2x. So what we'll do is change this into this form right here. And we'll actually do it twice. So this will turn out to be the integral of, and in place of this, we'll put what it's equal to. So this will be 1/2 of, and you've got 1 minus the cosine. And we're going to change one more thing, just a reminder on this. If this is a simple x, whatever this is, if this is x, this is 2x. And remember, it's just twice whatever this angle is. Well, in our case, our angle is 2x. So when we use the formula here, this will change into a 4x. So remember, you always double whatever the angle is. So since we started with a 2x on our problem, this is going to wind up being a 4x. So what this is, here's the first one. Now, you've got the same thing again, so you repeat it again. This is going to also be change into 1/2 of 1 minus the cosine of 4x, and that's also dx. So all you did there was take this one and turned it into this. Then you took this one and turned it into this. So you just use the rule twice. So now with that in mind, we'll go ahead and keep going through the rest of the problem. Okay, the next thing you can do, you've got a 1/2 times a 1/2, so you can go ahead and bring that outside the integral. So we'll make this be 1/4 of the integral of, and on the inside now what you've got is this. You've got this thing times this thing. Now to solve that, you're going to have to FOIL that. So 1 minus the cosine times 1 minus the cosine, and you'll actually FOIL it. So that's going to turn into 1. This first one's going to be 1. Then you've got minus the cosine, which would be minus 2 times the cosine of 4x. And then finally, you've got cosine times cosine. Both of them are negative, so this will turn into plus the cosine squared of 4x. Then all this will be in parentheses and dx right here. Okay, now what that does, you're actually going to have to make a second substitution now, because let's just take a look and see here. On this one over here, you've got the cosine squared, another cosine squared. Well, to find the integral, you're going to have to get a cosine to the 1st power. So you're going to have to use the half angle formulas again, but this time you're going to pick the one for the cosine. So let's take a look at that and just remind you of what that formula is. Okay, so the formula looks like this. You've got the cosine squared is this. And again, going back to our rules just from the very beginning, these things actually came from down here. The sine squared was equal to this, the cosine squared is equal to this. So we're really just working with the same formulas off the initial strategies. Okay, but now again, you have one more thing to change. If this is x, this would be 2x. But in your case, you've got a 4x here. So again, if this is 4x right here, then this one over here would be 8x. So remember, you have to double whatever it is that you've got. So what we'll do is rewrite this one, and we'll put this in the form. So you'll still have, some parts of it stay the same. The 1/4 stays the same, and you've got the integral of 1 minus 2 times the cosine of 4x. Then you've got plus, and on this now, you're going to change this into this form right here. So it's going to be 1/2 of 1 plus the cosine of 8x dx. So again, all you did there was change this cosine squared into its double or half angle formula. So it looks like that. Now what that does, you've got all the cosines to the first power, which is what you were looking for. So now it's just a matter of finishing up the problem. So we'll scoot things down just a little bit here and continue on. Now the next thing I would do is go ahead and distribute this 1/2. So this would be 1/4 of the integral of 1 minus 2 times the cosine of 4x. And take this 1/2 and distribute it. So this would be plus 1/2 plus 1/2 the cosine of 8x. So we'll run through all the algebra on this one. Okay, next step. You've got a 1 and you've got a 1/2. You can go ahead and put those together and make that be the integral. 1 plus 1/2 would be 3/2. And then minus, you've got the 2 times the cosine of 4x. And you've got 1/2 the cosine of 8x. Okay, now the next thing to do is this. Here you've got the integral of 3 separate parts. You can split each one of those up into 3 individual integrals, and that's what we'll do in this next step. So we'll make this be 1/4 of, now first of all, you've got this part, which would be the integral of 3/2 dx. Then you've got minus 2 times the integral of the cosine of 4x dx. And then finally you've got plus 1/2 times the integral of the cosine of 8x dx. And then we'll put brackets around the entire thing. So really it's just a matter of 3 separate integrals. And you'll solve each one of these things separately. Now this one will not require use substitution, but these next two actually will. If you look at them, what you're going to have on, treat them as 3 separate problems. On this problem, you're going to let u be equal to 4x, and on this problem, you're going to let u be equal to 8x. So that's going to be u. So let's first of all kind of look at the use substitution on these. On this little part right here, if you let u be equal to 4x, then the derivative, the differential of u, would be equal to 4 dx. And you just need to replace that dx right there. So again, just treat this as a separate problem all by itself. So that gets you to 1/4 du would be equal to dx. So on this problem, that's going to be your u substitution right there. Now let's look at this problem. This one lets u be equal to 8x. So again, the differential of u would be equal to 8 times the differential of x. And again, you just want the dx over here, so you want to substitute that right there. So that means that 1/8 du would be equal to dx. And on this problem, that's going to be your u substitution. So now with those, let's go ahead and continue through the problems. Okay, so first of all, you still got the 1/4 over here. Then you've got a bracket. Now this one you can go ahead and finish out. That's just a constant, so the antiderivative of that would be 3/2 x. Then you've got minus 2. Now the antiderivative of the cosine is the sine. So that's going to turn into the sine of, well actually let's write it first of all in terms of u first. first. So we better put it in u. So let's make this be the integral of the cosine. We'll put one more step in here. The cosine of u, and we'll put in here 1/4 du. So we'll put it in u before we actually find the antiderivative. Then over here you've got plus 1/2. And again, we'll write this as the antiderivative of the cosine of u. And on this one, we'll substitute 1/8 du. So let's take care of that first. And then put a bracket around the whole thing. So quite a bit of algebra in this problem. So we continue on. So this is going to be 1/4 of, now this one turned into 3/2 x. And on this one, you can bring this 1/4 out in front, which would get you to a negative, it'd be 2/4 or 1/2, the integral of the cosine of u du. And then on this one, bring the 1/8 out in front, and you'd have 1/16 of the integral of the cosine of u du. Okay, now that gets you to 1/4 of, this would be 3/2 x still, and then here's 1/2. The antiderivative of the cosine of u is the sine of u, so this will turn into the sine of u, and you'd have a plus c, but we'll save that for the end. Then you'll have plus 1/16 of, again, the antiderivative of the cosine is the sine of u. And then for the whole problem, we'll go ahead and just put a plus c out here. Now, you need to replace each one of these u's with what they're equal to. So this is going to be 1/4 of 3/2 x minus 1/2 of the sine of, and in place of this u, you're going to replace it with 4x right here. So this one's going to turn into a 4x. Then you've got plus 1/16, the sine, and again on this problem, u was equal to 8x, so you'll replace this one with an 8x plus c. And then the final step to the problem is just to go ahead and distribute this 1/4. So in the last step, multiply these together, you'd have 3/8 of x, then minus 1/8 of the sine of 4x, and then finally plus 4 times 16 would be 1/64 of the sine of 8x, and then tack on the plus c, and finally u would be finished. So that's going to be the solution right there. But let's go back up and just kind of look at the whole thing one more time, just from the top. Initially, take the sine to the 4th and split it into 2 sine squareds. Then take each sine squared and use this half angle formula right here for the sine. Now, move the 1/4 out and take what's left over, and right in here you actually foil these two together. So in here you're going to foil, when you foil these two you get this, but that introduces a cosine squared. So again you have to do a second substitution, this time the cosine squared, you'll substitute this. Now what that does, it finally gets all these cosines to the first power so that you can find the antiderivative. And then from there on out it's just a matter of algebra, and splitting it up from a single integral into 3 separate integrals, do a u substitution on each part that requires it, and when you finally get to the end, change it from u form back into x form again, and you've got it. So there's an example of a problem that actually required a couple of identities and a little bit trickier. Now I think I'll go back up one more time and show you at the top here. This works on a problem in this form. You split it up into 2 parts, but suppose you had a problem that looks like this. The integral of the sine squared of x times the cosine squared of x. Then in this case, go ahead and change this one into the sine form, go ahead and change this one into the cosine form, and you'll wind up doing it similar to this right here. So whether it's sine to the 4th or sine squared, cosine squared, essentially you're going to follow the same strategy. So there's a little bit trickier problem for you.